So we discussed Alfred Wegener's theory of continental drift, right? And that's the theory that he believes that the continents have drifted apart over the years, right? That they were once all together, that they were once all together in this giant landmass, like we see on this screen here. And eventually they drifted apart into what we now know as our world map. So that's his theory. So he also has evidence, 3 types of evidence, and they're listed here to support his theory. So the first type, he says here that he presented a variety of evidence. The first one is similar plant and animal fossils. The second one is matching rock types and mountain chains. And the third type is glacial evidence, right? I mean, we know that glaciers exist in very cold climates. And so he's going to talk about why he believes that that can help support his theory, that there was once one large landmass called Pangaea, and all of these continents have drifted apart into what we now know as our world map. Let's take a look at the first type, so matching fossils. Fossil evidence for continental drift includes several of the same organisms' fossils were found on different land masses. So Wegener is reasoning that these organisms could not have crossed the vast ocean, presently separating the continents. So he's saying, listen, if they were all connected, right, this is what we now know, but he thinks they were all connected before. Remember, like South America and Africa, they kind of look like they can match here. And so he's saying they were all together in one big landmass. And that's why there's evidence of some of these things, fossils, the remains, right, the dead remains of different organisms. But I do want to point out at this time, many scientists do believe that there were land bridges before that connected these continents. Although there's no signs of land bridges, right, that have connecting these continents, but that's what some modern day scientists believe. So the first type of evidence involved would be the Mesosaurus, right? This here, the Cygnathes, and the Lycosaurus. So these are 3 different types of organisms, okay, that now exist. That existed many years ago, right, in different periods, and I'll show you on the next screen. And so here we have our matching fossils, right? So we're going to follow this along by color, right? And it's going to show us what it looks like and what they believe to be some evidence here. So the first type, right, would be the Cygnathes, right? So I'm going to underline that here. So this one here. So look at this. The Cygnathes is in South America and Africa. So there's fossil remains of this living thing in South America and Africa. How is that possible if they weren't connected so long ago? This is what Wegener is saying. Okay, now let's move on to this green one. I'm going to change my color. Okay, so green. So that's the Glossopteris right here. So that's a plant, okay? His theory is that, look, it was in Australia, it was in Antarctica, also in India, in Africa, and found in South America. So all of those continents have the remains of that plant. Let's switch colors one more time. Let's go with maybe a purple. Actually, 2 more times, but we'll start here. The Lycosaurus. So the Lycosaurus exists in Antarctica, in India, and Africa, in these 3 different continents. So the theory is that they existed there, right, and these remains because they were all connected, like in this picture, okay? And last but not least, we'll switch to our blue, the Mesosaurus. Mesosaurus exists in South America and Africa. Right here they are, South America and Africa. So there's remains of these. So if they were once connected, then that's why we have those fossils in that area. And that's what his theory is. Okay? So this is how he's proving that there are matching fossils and that Pangaea, right, the really large landmass, once existed. Let's go to the second type. The second type of evidence is the matching rock types. Matching rock types in several mountain belts that today are separated by oceans provided evidence for continental drift. Okay, so see all of this section here. I'm going to go back to my pen. So see all of the the brown edging here. So this is all examples, all of the brown I'm trying to circle. Okay, so these are all examples of mountains. Now, if we look, right, so here's the example. The Appalachian Mountains are in coastal North America are similar in age and structure. So similar in age and structure here, the Appalachian Mountains, as those in the British Isles and Scandinavia. So here's the British Isles and here's Scandinavia. So this all looks like it could be together, right? So if they were all pushed together, right, and connected, like Pangea, like the theory says, then maybe that's why the mountains match and look the same there. Okay, so that is his theory. The third type of evidence that Wegener suggests is glacial evidence, right? So glaciers, large sheets of ice, right? And we know that glaciers are cold, right? And they exist in cold places. Let's take a look at his evidence. So Wegener found glacial deposits showing that between 220 and 300 million years ago, ice sheets covered large areas of the southern hemisphere. So the southern hemisphere, right, that's where we're going to find like under the equator, right? The equator is the imaginary line that separates the northern hemisphere, the top, from the southern hemisphere, bottom, okay? So here's what Wegener is saying. He's saying that we found evidence of glaciers, okay, in southern Africa, South America, India, and Australia. These are all places that, as it says here, have temperate or tropical climates, meaning they're kind of warm places. So if they're warm places, why do they have evidence of glaciers? Okay, and so this is why he believes that glacial evidence is the third type to prove that Pangea existed. Okay, that the theory of continental drift is true, that we used to have one big landmass that looks like this, and they eventually drifted apart, which means moved apart to what we now know as our world map.